Question 11. An elephant of weight 45,000 newtons stands on all 4 feet on the floor. The average pressure on the floor is the elephant foot in contact with 34,000 Pascal. What is the area of each foot? We have the equation pressure equals force over area. We need the area. So area equals force over pressure. Force here is 45,000 Newton and the pressure 34,000. It gives you about 1.3 meter square. For 1 foot, the area of 1 foot, 1.3 over 4 gives you 0.33. Question 12. Some air trapped inside a metal container with a tightly fitted lid. As you see here, the container and tightly fitted lid means there is no gas escape outside. The container is heated strongly behind a safety screen. This lid is blown off by increasing pressure. The lid is blown off by the increasing pressure of the air inside. What causes the increase in pressure of the air inside the balloon? Each particle expands and takes up more room. Particle does not expand. Whole volume of gas of air expands, yes, but the particle does not expand. The air particles move more quickly is correct. Air particles move more correct. The number of particles inside the container increases. No, the amount of air is constant, so the number of air inside the container is constant. The volume occupied by the air decreases. You see here the same volume. So all of this is wrong except air particles move quickly. A very hot mug of coffee is near a large unheated swimming pool holding 2 times 10 power 6 of water. Which statement is correct? If the mug of coffee is dipped in the pool, the coffee will lose much more internal energy than the water in the pool can. No, actually the coffee will lose the same amount of internal energy as the water pool cans. The internal energy of substance depends on only temperature. Internal energy is the sum of kinetic and potential energy of the substance. Depends on temperature and the volume and the pressure, not just temperature. The internal energy of water in the pool is lower than the internal energy of the mug. Actually, no. The internal energy although the mug of coffee is more hotter than the water, but the molecules of water is much more. So we're talking about a pool. The molecules of water much more in number than molecules of water or the coffee inside the mug. So the internal energy is the sum of the energy of the molecules. As we have in the pool, much molecules. So the internal energy of the pool is much greater than the internal energy of the mug. When the temperature of the mug of the coffee falls, the internal energy will decrease. Is correct. When the internal temperature of the mug decreases, the internal energy also decreases. A student measures the mass of water of an open container over 2 hours. The container is kept in a warm room. The results are in the table. So we have a container and we have a scale, and we measure the amount of water and we measure the mass of water, the decrease in mass over time. Decrease in mass of water, the decrease in the mass of water over time. As you see here, the mass of water decreases per time 33.9, 30.6, 27, 24, 22. Why does the mass of the water change? Because, of course, of the evaporation, not boiling. The water evaporates, this is correct. The water freezes, the water condenses, the water boils. No, the water does not boil, as does no heating here. It is kept in a warm room. So when the water evaporates. Number 15. 1 kilogram of aluminum requires more thermal energy to raise its temperature by 1 degree than 1 kilogram of copper requires. Why is this? From this equation, E thermal energy required to raise the temperature equals mc delta T. So the energy required depends on the mass, specific heat capacity, and delta T. Mass is constant 1 kilogram of aluminum and 1 kilogram of copper. Delta T is also constant 1 degree Celsius. So energy here required depends only on the specific heat capacity. So aluminum is better conductor, aluminum is poor conductor, aluminum has higher specific heat capacity than copper, lower specific heat capacity. No, aluminum has higher because here the energy required here is more. So aluminum has a higher specific heat capacity than copper. A block of ice at temperature of minus 100. Energy is supplied at a constant rate. The graph shows how the temperature changes. Change from minus 100 to 0 and constant for a while of time. Then from 0 to 100, then constant. At which point have its ice completely changed state to water, and all the water completely changed to state to steam. Ice completely changed into water. Here is ice. The temperature of ice increases from minus 100 to 0. At 0, there is no increase. All thermal energy supplied used to change the temperature state from ice to water. So at this point, the ice is changed into water. Here is at 2, all ice changes into water. So at this point, all ice changes into water, and so the temperature of water starts to increase again. Till it reaches boiling point. At boiling point, all water or the water start to change into gas. From 3 to 4, here all energy or thermal energy supply used to convert water into gas. At 4 here, all water changed into gas. So at 2 and 4. Water waves are reflected at a plane surface. Which property of waves is changed by the reflection? Talking about reflection, nothing changed, only the direction. The frequency is the same, speed is the same, wavelength is the same. No change, only in the direction of the wave. A light rays pass through air, glass, and water. At which point does the light speed decreases? The light speed decreases as it moves from air to glass. So at this point B, and at this point Y. Here X shows the answer is W and Y. Question 19. Plan water waves approach a narrow gap in a barrier, which diagram shows the diffraction pattern that would occur. As you see here, the width of the gap is almost the same as the wavelength. Width of the gap is almost the same as the wavelength. So we have here the maximum diffraction. As the wave diffracted, the wavelength stays the same. before and after. Here we see that there is an increase in the wavelengths. Now, here is the same wavelength, so the answer is C. A ray of light enters a transparent plastic widget from air, and it is incident on the lower surface at the critical angle. The angle of incident is I, the angle of reflection is R, the critical angle is C. In which ray diagram are the angles labeled correctly? This is angle of incident, yes, and this angle of reflection, and it's not the angle, the critical angle. This is the critical angle. Okay, this is not the critical angle. Here is incident, reflection, and this is the critical angle. B is correct. For the here, this is I. Here's the incident angle between incident ray and normal. R. This is R, not this one. And C correct. Here is I, also wrong. This is I. This is R, correct, and this is wrong. Critical angle. So the answer is B.